Today's daily LeetCode problem of the day is filling bookcase shelves number 1105. For this problem, we're given an array of books, where books of I is equal to the thickness and the height, which indicates the thickness and the height of the ith book. We're also given an integer shelf width. We want to place these books in order onto a bookcase shelf that have a total width of shelf width. We choose some of the books to place on the shelf such that the sum of their thickness is less than or equal to shelf width, then build another level of shelves on the bookcase so that the total height of the bookcase has increased by the maximum height of the book we just put down. We then repeat this process until there's no more books to place. So we want to note that each step of the above process, the order of the books we place is the same order as the given sequence of books. So for example, if we have an ordered list of 5 books, we might place the first and second book onto the first shelf, then the third book on the second shelf, and the fourth book on the 5th shelf. So we want to return the minimum possible height the total bookshelf can be placed after placing the shelves in this manner. What does this mean? So this note simply means that we are not able to sort the books. We don't want to sort them and say, put the 1 1 1 1 1 1 1 1. For example, we don't want to sort them. We want to use a dynamic programming solution. What does that mean? We are going to solve the smaller problems to solve our bigger problem. We will solve each shelf on its own individually, and by solving each shelf on its own, it will eventually solve our total problem in a whole. So our constraints, book length will always be between 1 and 1000. Thickness and shelf width will always be between 1 and 1000, and the height will always be between 1 and 1000. So for this problem, we're going to take a dynamic programming bottom-up approach, meaning that we are going to solve it layer by layer in order for our books. But each time we come across a new book, we're going to start it on a new shelf. We're then going to try to take all of our previous books and rearrange them on this shelf to create a new minimum height. If we can't do that, we will just leave the book where it is and move on to the next book and then do the same thing. So we're going to always try to make a new minimum height by rearranging the shelves after putting a book on a new shelf. So how do we do this? We're first going to initialize a dynamic programming array that's going to be a books.length plus 1. This is because dynamic programming of 0 is going to be equal to 0. We've placed 0 books. Dynamic programming of 1 is going to be of the height of book 0, 1. We're then going to loop through the books starting from book number 2, build a new shelf to hold the current book, and then have a while loop to calculate the height of the previous books as they're added onto our new shelf. So we're going to increment backwards. So we're going to create a new variable j that is going to start at I minus 1 and increment backwards to try and put all of our previous books onto this new shelf to see if we can reorganize it. So let's do this. We're going to have a new integer array, dp, which is going to be equal to a new int of books.length plus 1. We're then going to initialize our base cases. So dp of 0 will be equal to 0. dp of 1 will be equal to books of 0 of 1. We can then start our for loop to increment from book 2 onwards. So for int I is equal to 2, as long as I is less than books.length I plus plus. So what are we going to do in this for loop? This for loop is going to calculate the remaining width based off of whatever book we put into the shelf, the max height basing it off of the current book that we put onto the shelf, and then we can update our dynamic programming array of I based off of the book we added previously as well as the previous value of dynamic programming of I minus 1. So that way, later on in our while loop, we can compare it to our rearranged bookshelf. So we're going to have an integer remaining width, which will be equal to the shelf. It will be equal to the shelf width minus the previous book. So books of I minus 1 of 0, the width of that book. We will then have an integer max height, which will be equal to books of I minus 1 of 1, so the previous book's height, and we can then update our dynamic programming of I, which will be equal to the current max height, so max height plus dp of I minus 1, or the previous layer's height. We now want to initialize our j variable. Our j variable is going to be the variable that is going to traverse backwards and get all of our previous books to see if we can rearrange them on this shelf. So integer j will be equal to I minus 1. So while j is greater than 0 and the remaining width on our current level is minus the previous book's width, so books of j minus 1 of 0 is greater than or equal to 0. So as long as we still have room on this shelf to work with, we are going to update our max width and our dynamic programming array. So our max height will be equal to the math.max, and this is simply going to find the max height of this layer, and that will be based off of the tallest book we put on this layer. So it'll be equal to either max height or the books of j minus 1 of 1, so the previous book's height. We can then calculate the remaining width, so remaining width will minus equal books of j minus 1 of 0. So the remaining width on our current shelf is subtracted from the previous book's width. And then we can upgrade or update our dynamic programming array, and we want to find the minimum height. So it's either going to be what it already is, or the new shelf we created is shorter than the previous shelf. So we can do dp of I is equal to math.minimum of dp of I, or the max height of this current layer plus the dp of j minus 1. So we're looking at the layer that j was previously on, and then we're adding the current new max height to it. If that is shorter than what we previously established up here, we will update this to be what we previously to the new height, or we'll leave it the same. Then we want to j minus minus to see how many books we could stack on here. So we can move this right here. Now we should simply be able to return dp of books.length because it's all adding up. This will be the last value we calculate. So we want to make sure that we include books.length right here. So less than or equal to books.length. So if we run this, passes our test cases, and if we submit it, passes all solutions. All right, let's try it in Python. So to do this in Python, it's pretty much the same. We're going to initialize our DP list. It's going to be consisting of zeros, so we don't have to initialize the zero index on its own. And it's going to be of length of books plus 1. We can then initialize the first index as books of 0 of 1. And then we can do our for loop. So for I in range 2, comma, the length of books plus 1. And then we're going to update our width. So remaining width will be equal to the total width minus the previous book, so shelf width minus our previous book is books of I minus 1 of 0. And then our max height will be equal to books of I minus 1 of 1. And then we can update our dynamic programming array. So dp of I will be equal to our previous book height plus our previous dynamic programming value. So max height plus dp of I minus 1. We then initialize our variable j, which will be equal to I minus 1. Then our while loop is while j is greater than 0. And while our remaining width minus the previous book's width, so books of j minus 1 of 0 is greater than or equal to 0. We can then update our max height. So max height will be equal to the max of either max height or the previous book. So books of j minus 1 of 1. We can then update our max width or our remaining width, which will minus equal books of j minus 1 of 0. And so we're subtracting that width from our shelf space. And then we can update our dynamic programming array again. So dp of I will be equal to minimum of dp of I, and our max height plus our previous dynamic programming, so dp of j minus 1. We can then subtract j minus equals 1, and then return dp of books, length of books. So if we run this, pass our test cases, and if we submit it, passes all solutions. So thank you. Follow for more daily LeetCode solutions.